Hello, good morning. Today we will study about chemical kinetics. First of all, we discuss about the rate of a reaction. Definition of rate of a reaction. Reaction rate. Rate of a reaction is defined as change in some variable per unit time. Reaction rate is change in concentration per unit time, and rates are determined by monitoring concentration as a function of time. Rates are determined by monitoring concentration as a function of time. Rates are negative for reactants and positive quantities for products. Here in this equation we can see the rate of reaction is expressed in terms of reactants and in terms of products. Types of reaction rate. Instantaneous rate, rate at a specific time, and average rate, delta A, over a specific time interval. Initial rate, instantaneous rate at t is equal to 0, that means where time is equal to 0. Nature of rate of a reaction depends upon various factors. The factors which affect reaction rate are nature of reactants, effective concentrations, temperature, presence of catalyst, number of steps. Nature of reactants. It depends upon the particle size. The degree of intimacy among particles obviously depends on physical nature of particles. Particles in the liquid state are closer than in the solid state. Likewise, particles in a finely divided solid will be closer than in a chunk of the solid. In both situations here, a large surface area available for the reaction to take place. This leads to an increase in rate. The smaller the particles, the faster the reaction rates. Nature of reactants. Ions react rapidly. Reactions which involve bond breaking are slower, which can be seen in the examples given here. Redox titrate reactions in solutions are slow. Transfer of electrons are faster than those of atoms. Reactions between covalently bonded molecules are slow, which is shown in this example. Concentration. For every reaction, the particles must come into intimate contact with each other. Higher concentrations, by definition, implies that particles are closer together than dilute solutions. So, rate increases with concentration. Then, surface area. Larger the surface area, higher will be the reaction rate. Temperature. Temperature affects rate by affecting the number and energy of collisions. So, an increase in temperature will have the effect of increasing reaction rate. Reaction rates and stoichiometry. Rate has units of moles per liter per unit time. Here we can consider a hypothetical reaction. A moles of A reacts with B moles of B, which gives C moles of C and D moles of D. So we can write rate of a reaction R is equal to 1 by A del A divided by delta T is equal to 1 by B delta B divided by delta T. This is equal to 1 by C delta C divided by delta T is equal to 1 by D delta D divided by delta T. For this reaction, which is given as an example here, we can express the rate of reaction in terms of the concentration of reactants as well as the products. Here an example is given, and how we can calculate the rate is given here. Then rate law. Let us consider a following reaction. A moles of A reacts with B moles of B, which gives product. Rate law is the equation describing the relationship between the reaction rate and concentration of a reactant or reactions. Rate is equal to K, A to the power m, B to the power n, where K is called the rate constant. Concentration and rate. General form of a rate law can be expressed as rate is equal to K, A to the power m, B to the power n. Here A and B are concentration terms, K is a rate constant, m and n are reaction orders. Reaction orders and thus rate law must be determined experimentally. That is, we can say that order is an experimental quantity. Reaction order. If the rate is expressed as K A to the power 1, B to the power 0, then m is equal to 1 and n is equal to 0. Here the reaction will be first order, and in terms of B, we can say that it is 0 order. So the overall rate will be equal to 1. Usually it may be written as rate is equal to K concentration of A. The values of the reaction order must be determined experimentally. They cannot be found by looking at the equation, that is the stoichiometry of the reaction. Rate law. M and N called reaction orders. They indicate the sensitivity of rate of concentration changes of each reactant. An exponent of 0 means the reaction is 0 order. In that reactant, rate does not depend on the concentration of that reactant. Rate law. An exponent of 1. Rate is directly proportional to the concentration of that reactant. If concentration is doubled, rate also doubles. That is, reaction is first order in that reactant. An exponent of 2, that is, rate is proportional to the square of concentration of that reactant. If concentration is double, rate is quadruple. That is, reaction is second order in that case. The overall reaction order is the sum of all the orders. Reaction orders can be shown in a tabular form in this example. Various examples are here where we can say how rate is doubled or quadrupled accordingly. Here we can say various examples.